All right, welcome back. It's Monty here. Our final week together with mathematics. And Mr. Miller and I are anxiously hoping to excite you about the possibilities mathematically in the world. And what better way to do it than with games, dice, cards. Now, we just spent like 10 minutes on this one sheet of paper with a deck of cards. Now we're going to look at different scenarios, and they can take time. We're not in a hurry. It's not about how many of them we get done. It's about the conversations we have and how you understand the problem as compared to your neighbor. Well, this is all about class discussions. So let's get started. Now, this is part 2 of the very first Monday, Tuesday of the last week of school, week 37, June 14th and 15th, okay? All right, so let's do another scenario with cards. All right. Now, the idea here is dependent events and given statements. We want to find probability. And the key is right here, showing calculations. What is it that's going through your mind compared to your neighbors? Okay? Now, again, we're not in a hurry. If you guys end up with great discussions, you could get one problem done. We're already, 16 minutes into class, and I'm in a hurry. Okay? All right. Determine the probability that each event will occur. Oh. Then determine the probability that both or all the dependent events will occur. Wow, what does that mean? If, then, is this some sort of science class? All right, now, a common deck of playing cards. Let's get our deck of playing cards. Includes 4 aces, altogether 52 cards. If you randomly choose 4 cards from the deck, what is the probability of choosing 4 aces? Well, we sort of did that with 3 of a kind, didn't we? All right, so now let's grab, we'll determine the probability that each event will occur. Okay, well, how many events are there? Serious, how many events are there? Randomly choose 4 cards. Okay, now, formal math. What's the probability of an ace? And let's try to do this. Ace. What's the probability of an ace? So that was a heart. And here's a diamond. Probability of an ace. Club. Looks like a clover. And the probability of the final ace, which I have to admit, looks like a teardrop, right? Spade. All right. There's 4 events. So what's the probability of getting an ace on the first draw? 1 out of 50. Oh, okay. Now that's one way to look at it. 1 out of 52. How many of you thought this? Probability of an ace on the first draw. 4 out of 52. Okay? See, we have all of them. They're all available on the first draw. Probability of an ace of hearts is 1 out of 52. Probability of the ace of diamonds, so on the ace of diamonds, now 1 out of 51, 1 out of 50, now. Okay, some of you might have thought this. Okay, teacher way. On the first pull, we have all 4 available, 4 out of 52. Now on the second pull, there's 3 aces left, 3 out of 52. Okay, and on the third pull, there's only 2 aces left, and we get 2 out of 52, and the 4th draw, there's only 1 ace left, and it's 1 out of 52. Okay? This is what the book is hoping for, that you described it like this. Okay? Now, the probability, what is the probability of choosing 4 aces? Okay? If you just reach into a deck of cards and grab 4 cards, 1, 2, 3, 4. Getting aces. All aces. Alright? That answer, probability, 4 aces in 4 draws, is not very likely. Okay? It's 4 out of 52 times 3 out of 52 times 2 out of 52 times 1 out of 52. Okay? This is a compound event given statements. Okay? 4 times 3 times 2 times 1. 4 times 3 is 12, 24. 2 times 3 is 6, yep, 24 over a massive number. And yes, Monty messed that up, 50. 51, 50, 49. How many people were screaming at me in the classroom, Mr. Miller? You know, that's the first mistake I made today. And it's basically the first thing I've done today. So, pause the video. Grab another cup of coffee. Oh, that's going to help. Get the gears. Alright. Gosh. I had it right over here. Okay, so now let's find out how big this number is. Okay? Oh my gosh, my head is a calculator. Oh, lordy, lordy. Alright, 52 times 51 times 50 times 49. Alright, 649, 70, 400, 64974. 6974. 6497. Boy, it's gonna be one of them days. This is why I don't get really mad when we write the wrong numbers on our answer sheets in math, because Monty does it too. 6497. 6497. 400. 6,497,000. Wow. Okay. So 24 divided by that crazy number gives us a really tiny number. Convert to a fraction, and it won't even convert to a fraction. Wow. So 24 times out of 6.4 million, we're going to get 4 aces. Now, hopefully, you pause the video, have a discussion. This is the idea of independent. Okay? This is the whole idea of independent. Independent. Okay? If you pull 1 card, probability is 1. Then the next time, probability is 1. Probability 1. Probability 1. The probability of getting the 4 aces randomly, given they're in a row, is right here. Okay? The teacher way. So, have that discussion. This is not wrong, but it's not, given the first one was an ace, what's the probability that the next one's going to be an ace? The next one after is going to be an ace. Okay? So, what's in yellow is the idea of dependent, given certain things have happened before. Alright, so we're 10 minutes into the video. On Wednesday, Thursday, we're going to continue this. All right? So have a great Monday, Tuesday, and being our last week, one Mathia session, one solo session. This is the type of work that we would like to see on the solo. Okay? If you only get a couple of them done, that's okay. It's not about volume. It's about you picking one and jumping in and getting messy with math. See you in the next video.